Hey everybody, and welcome to this video on solving one-step additive equations. So without further ado, let's get to it. Alright, consider the equation x plus 6 equals 8. Now before we start, what does it even mean to solve an equation? Well, in any equation to be solved, there will be at least one unknown quantity which will be written in as a variable. And to solve an equation means to find the number or numbers that when we substitute them in for the variable or variables makes the equation true. Now, whenever I think of an equation, obviously it means that the numbers on either side of the equation are exactly the same, and we say that we have a balanced equation. I like to envision a scale with an x plus 6 on one side and an 8 on the other, and the way we know they're equal is because the scale is balanced. So we have a balanced scale, we have a balanced equation. Let's say that each of these blocks with a 1 on it represents 1 kilogram, and we're trying to figure out how much this x block weighs. Since the scale is balanced, it means that x plus 6 is equal to 8. Now, perhaps you already know that this x block needs to weigh 2 kilograms, or the x in this equation is 2, in order for the two sides to be equal. Even so, we need to know what's going on behind the scenes and how to write this out and show all of our steps when solving an equation. So let's think about the scale first. What we need to do is have a balanced scale, but where on one side we have just the x block, and on the other side we have just some number of kilogram blocks, so we know exactly how much the x block weighs. In terms of the equation, what we eventually need is something that looks like x equals blank, where that blank is a number. That is, we need to isolate our variable. And isolating our variable when solving an equation means having the variable on one side of the equation and just numbers on the other. No variables on the other side. This is going to be a common theme when solving equations. All right, back to the scale. In order to keep a scale balanced, if we were to ever take off any weight from one side, we'd have to take off the exact same amount of weight from the other side in order for the scale, and therefore equation, to remain balanced. So if I were to take off 1 kilogram from the left side of the scale, I would have to take off 1 kilogram from the right-hand side to make sure that the scale remained balanced. If I were to take off 2 more kilograms from the left side of the scale, I would have to take off the same amount of kilograms from the right side of the scale to make sure that the scale remained balanced. And of course, we could take off as much weight as we want as long as we do it to both sides of the scale, and the scale will remain balanced. What does this mean in terms of an equation? It means that given an equation, we can subtract any number we want as long as we do it to both sides of an equation and the equation will remain balanced or true. Let's go back to the scale. Similarly, if we were to add any weight to one side of the scale, we would have to add the exact same amount of weight to the other side to keep it balanced. So for instance, if we added 3 kilograms to the left side of the scale, we would have to add 3 kilograms to the other side of the scale, and the scale would remain balanced. Of course, we could add as much weight as we want, as long as we add the same amount of weight to both sides of the scale, and the scale will remain balanced. What does this mean in terms of an equation? It means that given an equation, we can add any number we want as long as we add it to both sides of the equation, and the equation will remain balanced or true. So, one thing to keep in mind is this additive property of equality, which says that given an equation, we may add or subtract any number that we want as long as we do it to both sides of the equation, and the equation will remain balanced or true. Alright, actually time to solve this first equation. Well, when we look at our scale, in order to get this x block on one side of the scale by itself, we need to remove 6 kilograms from both sides of the scale. Let's do it. So we see that the x block weighs exactly 2 kilograms. If we think about this with regard to the equation, to isolate that variable, all we needed to do was subtract 6 from both sides of the equation, and we'll find the exact same solution, that x equals 2. Note, when finished solving an equation, it's a good idea to check our answer by substituting that potential solution in for the unknown variable in the original equation and seeing if it makes it true. Let's go ahead and do that. Awesome. So our solution worked. And note, when I check a solution, I like to let the reader know exactly what's going on. So I substitute my value in for the variable by putting a set of parentheses around it, even if I don't technically need to. It tells the reader, hey, I'm substituting in blank for this variable right here to make sure my solution works. I also write a question mark above my equation sign to signify that we're checking to make sure that this statement is true. That is, we don't know yet, but we will soon. And once we do confirm that the equation is true, I write a little check next to it to tell the reader that everything is good and our solution works. All right, let's try another one. How about the equation m plus 9 equals 12? All right, so we need to find the value of m that makes this statement true. Or we need to figure out how much this m block weighs on this scale, which represents the exact same equation. Well, on the scale, it's obvious to see that to get that m block by itself, we're going to need to remove 9 kilograms from the left side of the scale and 9 kilograms from the right side of the scale. So let's do it. So from here, it's clear that the m block weighs 3 kilograms, so m must equal 3. With the equation, in order to isolate that variable, all we need to do is subtract 9 from both sides of the equation, and we see that, again, m equals 3. Now, eventually, we like to be comfortable solving these equations just looking at the mathematical notation below. But it is really helpful to continue to think about these with regards to the scale. All right, here's another equation. W minus 5 equals 6. Now, it might be a little bit easier to begin by solving this one using the equation. Of course, we want to isolate that w on one side of the equation. And to do so in this case, I think the best thing to do is to add 5 to both sides of the equation. Then we end up with w equals 11. So that should be our solution. And if we check it really quickly, indeed, 11 is the value to substitute in for w that'll make this equation true. Now, thinking about it with a scale, it's kind of hard to visualize negatives. But if we look at each of these balloons here, each of these balloons pulls up on the scale with a force of 1 kilogram. So each balloon pulls up with 1 kilogram. Each of these 1 kilogram boxes pushes down with 1 kilogram. So how do we isolate that W box on the scale? Well, we need to add 5 kilograms to the left side of the scale to counteract those 5 balloons, and then the left side of the scale will weigh exactly W kilograms. So let's add 5 kilograms to both sides of the scale. All right, so each of those 1 kilogram boxes and 1 kilogram balloons on the left side of the scale, they kind of cancel each other out. They effectively weigh absolutely nothing because they balance each other out. So let's just get rid of them. All right, and so just like we thought with the equation, we see that that W box weighs exactly 11 kilograms, so W equals 11. All right, now it's time to try solving some equations without the use of the scale model. How about k minus 8 equals negative 2? Well, we know that eventually we want to turn this equation into one where we have just k equals some number. We want to isolate k. Well, how do we do that? I think we need to add 8 to both sides of the equation. Adding 8 to the left-hand side of the equation will counteract this negative 8 right here, and they'll add to 0, leaving just k. If we add 8 to the right-hand side of the equation, we end up with k equals 6, which should be our solution. Awesome. That solution checked out. Let's try another one. How about b minus 4 equals negative 9? Again, we're trying to manipulate this equation, so we end up with b equals some number. How are we going to do that? How are we going to isolate b? Well, I see that we have a b minus 4 on the left-hand side of the equation, so adding 4 to that should end up giving us just b. The 4 and negative 4 add to 0. So, of course, what we do to the left-hand side, we must do to the right-hand side. And we end up with b equals negative 5, which should be our solution. Awesome. Again, our solution checked out. All right, now it's time for you to try to solve some equations all on your own. In front of you, you got 6 equations to solve. And note that while some have fractions or decimals, the strategy is absolutely the same with these types of equations. Just add or subtract whatever number you need from both sides of the equations in order to isolate your variable. So why don't you pause the video and take care of these 6, and when you're done, play the video and we'll see how it went. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.